Yeah, this is just the slides from your EWS leadership. So, hi, my name is Adam Mazouz, and I am a cloud solution engineer working here at Pure Storage, and I'm focusing on everything cloud in Pure, which includes Cloud Block Store. What I'm doing on my daily basis, I test, document, evangelize why and how Pure in the cloud. I'm constantly looking and searching for new use cases, new integration points. And it happens that I'm also a AWS community builder under storage category. This is the proof. I got swag this year. And I'm not wearing it because it just it's gonna hide me from your faces. So in today's session, I'm gonna walk you through how do we optimize, tune, and try to make the best out of AWS storage for running mission critical applications. I'm also going to deep dive into the difference between where are those mission critical applications we're running for ages now on the premises storage against the AWS native block storage. And the last thing I want to announce, which is really being announced by AWS back in January this year, is the new AWS SAN in the cloud. And I'm also going to try to make how we in Pure are making the same efforts to bring the SAN in the cloud and what is the benefits around that. And also, of course, there's going to be a demo at the end of this discussions. So what is a mission critical applications? So I stole this definition from Wikipedia. And at the bottom line, and like a general definition, it's the software or a database, an application that a business is really relying on to running their business. That means that if it's going to face a brief downtime or an outage in however piece of or component of their system, there's going to be negative consequences, which is likely is going to be financial. So a couple of examples for where you can find those systems are online bank systems. Finance systems are already relying a lot on mission critical applications, railway, aircraft operating, and also healthcare services. So we really, when we design those mission critical applications, they're really going down into a couple of examples here. The first one is enterprise applications, which includes any enterprise resource planning like SAP HANA, not HANA, but SAP ERP, Oracle version of it, and also Microsoft Exchange, and anything VMware, actually. It's mostly running mission critical applications on top of VMware stack. Relational databases is also another example or a type of mission critical applications that include, of course, Microsoft SQL servers, Oracle databases, SAP HANA, and all of those systems that a lot of customers, gaming, e-commerce, that relying on transactions coming into those systems, and enterprises are relying on giving all the performance, list downtime, etc., all of those storage terminologies that we're going to be going through. So if we're really going to go down into what is the requirements for building such systems? So I try to not to go with a long list. So we have 4, and mostly they're going to be storage oriented, because this is really what matters when we're building mission critical applications, or from my side of the world. The first one is we have to maintain low latency and constantly pushing high IOPS and throughput to the systems. Capacity and performance scalability is really important. And any enterprise grade storage features, data copy management, as you know, snapshots, replications, encryption at rest, encryption at transit, all of those features are really at the bottom line are related to the storage component of the mission critical application stack. There's also going to be compute, networking, but what is really making sure that those are resilient, those are performant, are the storage underneath. So the conclusion here, storage really can break or make your application. Before I'm going to start like walking through like AWS block EBS, the Elastic Block Store, and what its benefits, cons, pros, and all this the components and deep diving into best practices, I think we need to step back a bit and we try to compare or differentiate between the difference or where those applications were really running. So they were by ages now, decades, mission critical applications were running on premises storages. And us as Pure Storage, other vendors, we've been designing and trying to come up with new features that giving the benefits to those enterprise customers. And I think in order to understand the differentiators here, we need to speak the language of storage. So in order to do that, I'm just going to go through every terminology that I'm going to be using during this presentation. And I'm going to go into define these terminologies into 4 sections, I believe: performance, resiliency, efficiency, and cost considerations. So first, I'm going to start with performance. There's 3 to 4 measurements that if I'm going to be designing a system that is really performance, I need to measure a couple of metrics that they're going to give me or calculate me the performance. The first one is the IOPS. If you haven't heard about it before, that means that maybe you haven't touched storage before. But if you really know about it, that means that you really give a lot of thoughts when you've been provisioning storage with this. Because IOPS means it's the input and output operations per second, and also means that it's how much it takes or how many requests, read or write, that you can push from your storage system to your application server per second. And we usually define those or we're testing them under 2 important or a couple of important considerations here. The block size. Each application has its own block size, and the industry default is 4 kilobyte. If you don't know what the difference between kilobyte and kilobyte, that's a different topic here. I don't want to deep diving into it, because we kind of, as humans that we're trying to use technology that's technology relies on storage, we've been fooled by within a lot of years with this difference between terabyte, kilobyte, and etc. The basic example here is that if you purchase a hard disk, 1 terabyte hard disk, and you put it in or you hook it in your Windows laptop, what you're going to find is going to be 931 gigabytes. I'm sure that many of you have seen this, and you're going to be like wondering, where is the other gigabyte wins? Are they being fooled? Is this something that their marketing are really fooling us with buying less 1 terabyte? But in the bottom line is just how Windows is really, or the operating system layer is reading the 1 terabyte, which goes it's in 1 gigabyte, and this is what the Windows is giving you. However, okay, if you want to know about this, you can just send me a message in LinkedIn, or just catch me up after this. I'm gonna explain it to you in very details. The other thing is the random access and the sequential access. And this is really important in order to understand the decision for your access pattern for your that your application is gonna go and read or write from your storage system, or where's the application is reserving or storing this data. I'm gonna have a couple of examples for this for later on, but I need really to catch up with other terminologies here. Throughput is the measurements of how much data that or read and write requests that the system, the storage, that can push through the network or through the buses in the same system to your operating system layer. And the formula for this is that if for an example, if you provision an EBS volume that it's 3000 IOPS, and your file system or your application is designed for 4 kilobyte, you would end up with 12,000 kilobyte, which is per second, which is 12 megabyte per second, which is mostly, this is the formula that I'm using when I need to know how much throughput my system is gonna handle based on how much provisioned IOPS I'm gonna configure while I'm creating the EBS. But this is something else I need to walk through it again later. Latency is another really sensitive area when we're talking about provisioning storage, because it really defines the round time, or the time that the request is gonna travel from your storage to your operating system, and the operating system gonna acknowledge it back to your server. And whether it's gonna be read or write, it's really can affect the whole performance. And it depends on a lot of criteria, but one of the things I really always try to deep dive into is the queue depth. If any one of you here have configured or played with ESXi servers by the years, it's always a best practice to go into your host bus adapter that it's in your server and check their configuration and what is their best practice for queue depth. Because what the queue depth means, that means that how many, the numbers of requests that are still pending for my application, or my application waiting for the storage system to process. And for transaction sensitive systems, let's give this example. Transaction sensitive, transaction based or transaction systems like SQL databases that relying on sending back and forth financial packets, whatever they are, there really are an IOP latency, which means that the more I'm maintaining to maintain a high IOPS to fulfill all this transaction, because it does matter for me to perform very fast, I need to maintain low latency. And while I'm maintaining the low latency, that means that I need to maintain a really low queue depth. The lowest queue depth I have, that means that there is no pending IOPS waiting for me. And if you think about it, in the other hand, if I have a throughput-based application, it's the difference. I need to maintain a high throughput, which does not mean it does not rely on latency. The larger or the bigger the queue depth, the more I can push, because I'm sending larger packets, larger IO sizes. I think I talked I took my time here. I need to speed up a bit. Then resiliency, that's the other subject, is that we have two important things I'm going to talk about here briefly. Availability, which is what we refer as the nines. So if you go and check the GB2 or a GB3, which is the general purpose SSD based disks in EBS, you're going to find that it's 3 nines, which means that the annual failure rate here is just 3 nines, which is if you convert it to time, I think it's 13 minutes per year, something like this. Don't judge me on this, but it's just what is the participation of the failure of this device from the provider, because this is a vendor who's need to give these numbers. The other really important thing here, which is inevitable for any system or any hardware system that was not planning or strategizing for this, for a failure or an outage or a downtime, is really going down and find out 2 questions. The first question is, how much data can I afford to lose, which is, it means the recovery point objectives. And the second question is how fast that I can recover, which means the recovery time objectives. If you have ever went through any documentations of security mitigations or ransomware, it's always when you defining a backup strategy or a disaster recovery strategy, there's always these 2 terms that it's really depends on how fast it can retrieve from an outage. Lastly, I'm going to talk about the provisioning, which is a really fun topic, because because it's really a differentiator between the SAN system, which is storage area networking. I'm going to explain this in a few slides. And when I'm provisioning a cloud storage device or an EBS volume, is the difference between allocated space and an actual space. The actual space is usually what the host is already data written into the system. The bytes that the host is written to or is going to be reading from. The other thing is the allocated or the provisioned, which is what you as a user, when I go to create an EC2 instance and go down to define the storage section, I need to give how much terabyte or gigabyte my system is going to consume. And the difference here is what are you paying for? Because at the end is that your cost and billing is going to affect your, I don't know, your enterprise or your system and then you're going to be like thinking about how I'm going to optimize this from a cost perspective and etc. So two terminologies here, thick and thin provisioning, which is exactly what I've been telling you about. The thick provisioning means that I'm going to purchase this space. I'm physically pre-allocating all the bytes. That means that my file system is going to write zeros to everything. I'm owning it. In the thin provisioning, the other side of provisioning here is that it's giving you a virtual space, and you only the system is actually, you can see the whole size, but you can, let's say if you have a shared storage system, you can give back the other size to other systems. That means that it's more saving, and you are really having efficiencies in your aggregated storage, which is, I guess, where this is discussion is going to go into. So very quick comparisons here. So on premises, we have mainly three storage provisioning. One is you have your storage locally attached to your system, which the server is going to be like local disks, what we call them. Then you're going to have some RAID configurations, etc. The other thing is direct attached, which is you have this block of disks. Sometimes you call them disk pools or I forgot other terminology for this, but we call them dedicated or direct attached storage. The last piece is the shared one, which is it usually can be a SAN or a NAS, which is a storage area network, or a network attached storage, which is here. Difference is just the protocol that the systems or the servers can access this. If it's a NAS, it's going to be like NFS or SMB. If it is SAN, it might be through FC, iSCSI, NVMe over Fabric, name it. On the AWS side, there's usually, so far there's two. The instance store, which is the ephemeral storage that your instance is gonna start with, and it's just ephemeral, means that when you stop or terminate, you're gonna lose all the data there. And the other one is the direct attached elastic block store, which is behind the scene. It's just some storage systems that are located in the same availability zone where your EC2 hosts are dedicated to you. So at the end here, we know that storage means different in both worlds. Resiliency doesn't mean the same. Efficiencies is not the same, because in on-prem you have the thin provisioning. Your systems can have the duplications, compressions, all this add up for you, and also built in the cloud. There's thicker provisioning for both capacity and provisioning. I'm gonna for capacity and performance, because when you provision a storage, you also give the IOPS size and cost considerations. So the thing is here, and what I'm leading you, is how I can get the best out of the storage that the cloud is providing for me. So to tune it and optimize it, there's a couple of best practices that I've been myself following from the time I started doing things with AWS. And there's a couple of trade-offs. So when I'm gonna select an EBS volume, I'm gonna end up with a couple of considerations, or I call them trade-offs. And it does mean that from a decision or an access pattern for my applications, I need to go down and see what is my application is going to go with the storage. Do I need a throughput-based storage, or do I need a very high performance storage, which is IOPS in here? So, but with this, I need to know like, okay, do I need snapshot capabilities? Do I need multi-attached? This is another very, very, very important subject when you are configuring applications. And by the way, I think I missed something in the beginning. And I know that most of you might be really, really tic-tacky into the cloud realm. But when I'm talking about mission critical applications here, I'm specifically targeting those enterprises that I've been dealing with my years here in, actually it's 2 years here in Pure Storage. And we can see them, they're really afraid of getting their applications to the cloud because of those pain points that the cloud still didn't deliver. And what they call, and in the same time, they want to get the burden out of their shoulders of capacity management of their SAN storages in on the premises, the capital expense of their arrays, name them, the upgrades, etc. All this managed services that AWS is already providing for us, right? And in order for them to lift and shift their workloads from data centers to the cloud, AWS here, they've been doing a couple of things. And the best practices that I'm going to be following after this slide is kind of what we've been doing. And I think it's kind of mimicking the way that they've been used to do things with storage on the premises. This is why I think AWS is really investing hardly in this, in how to try to grab all of those enterprises to get all the applications on their systems or on the cloud. The first thing is you need always to use the newest offerings. If you're using GB2, you have to start using GB3. The reasons why, because there's a lot of cost considerations, throughput-wise, IOPS-wise, and also if you're using IO1, if you're going to be transiting to IO2, that means that you have more freedom when you're provisioning IOPS, because now you can scale your IOPS without relying on the capacity. In the past, when you want to provision, if your system wants, let's say 100, or I don't want to go wild, 60,000 IOPS, you really need to scale the same thing linearly within the capacity. So for that, you need to have like 6 terabytes of volumes that you don't need. You just need 100 gigabytes, but you have to provision 6 terabytes in order to get the IOPS, provision IOPS you need. And this is what we call wasted or over provisioned. And don't think about this just for one volume. Think about it, a couple of them, and how much is going to affect your bills at the end of the month or the end of the year, however you're doing your finance. The other bits of practice, and I think this is really, as I said, is how it's mimicking how it's been doing, is when to use RAID. RAID is the redundant array of independent disks, and basically is that you're getting a couple of disks or volumes, and you put them all together under one configurations. However, your RAID is B. So one, you can have a RAID 0. And RAID 0 means that you really are stripping down all your data into a bunch of disks. Sometimes I refer to it like you can think about it, you are aggregating your storage, but you're not giving back any protection or redundancy. And this is what it's going to be about. So when to RAID is when you have requirements of over 16 terabyte or gigabyte here. Your throughput requirements are above 1,000 megabyte, and your IOPS requirements are above 64,000. And why we're doing this, why when you're doing this, because you are like, for an instance, what I've been referring to RAID 0 is that you are giving your file system multiple volumes that when you're requesting reading or write requests or operations, the operations can strip down into your couple of the volumes that you are rating together. That means that you're already having your capacity aggregated, your IOPS, and throughput. However, not every RAID is a best practice, because EBS data is already replicated between availability zones. So you don't need to really have RAID 1, which is really splitting your storage into two, which means it's what we call mirroring. Actually, if you have two volumes and you put it in RAID 1, it means that you're splitting your capacity, and also wherever you're writing in volume 1, your file system is writing in volume 2. So you're ending up with a redundant data, but this is what AWS or the AWS users are not finding as a best practice. Another one is a snapshot restore. So what is happening behind the scene when you are restoring a snapshot from an S3 bucket? This is where your EBS, when you're with your EBS is really putting the snapshots or point in time snapshots, is that you create a volume from this, or you clone a volume from that snapshot, but you're not having a very performance from this volume, because AWS is getting back to you where your bytes whenever you access them, and this is what we're calling lazy loading, which means that this is going to affect your performance in general. So in order to address this IO latency, there's two solutions here. One is forcing initialization of the volume, and for Linux systems, what we do is just going to run a dd command that reading all the blocks in that disk. This means that you're going to forcing the initialization for that before you're getting your volume into production. And the second thing is the new features that I don't know, I think that was last year announced, is the fast snapshot restore, which is a capability that is charged hourly, I think, and it gives you a low latency or full performance access, but also you're going to be charged for. The third best practice I'm going to be showing today is actually it's a couple of, is that you have to choose your EC2 instance carefully, because each EC2 instance at the back end has a dedicated network to the EBS systems. It's different than the network tunnels that what you're going to be communicating through in your VPC or the outward, but this is just for the EBS system, and each one has it starts with 5 gigabit per second to 50. So you really need to choose carefully there. The second thing is you have to choose the EBS optimized ones. If you already have one, you're running your workloads on an EC2 instance that is not enabled, you have to enable it, but you are required to stop it first, and then which can lead to downtime. But what is EBS optimized actually? Sorry, I didn't give you a definition here, which is just going to give you a dedicated bandwidth and capacity from an IOPS perspective to the EBS system. Lastly, one of the things that I'm really following actually when I'm designing any SQL or Oracle is that each volume for those applications are really not using the same performance, not the same volume layout or volume IO sensitivity perspective. So for boot or general purpose, it's just you're going to be using GB3. Data files, you really need to data and logs actually, and this is where latency is really playing a game here, because this is where your system is going to be writing data or just throwing the logs there. And retrieving this needs a provisioned IOPS volumes in order to fulfill the needs of the systems. I talked about the relationship between provision capacity and provision IOPS, and how you can sorry, I need to check the time. I feel like I'm good. So the relationship between the IOPS and capacity, and how you try not to or eliminate or try to avoid overspending or over provisioning. So I have this chart here, which is an example of two VMs. One VM is requiring 20,000 IOPS. The other one is requiring 18,000 IOPS at peak times. Okay, so in order to design this application with this volumes, I have to provision this with the peak time in considerations, right? But think about all the wasted areas. So I'm going to be provisioning with the dashed lines, but I'm just going to be using what I provisioned just for a certain amount of time. And this is what we call inflexibility in performance, which means that you are ending up with paying a lot of money just to provision this IOPS at this specific time. In this, one of the problems a lot of customers they've been yelling about, and AWS actually heard them, and they announced this AWS SAN in the cloud in the beginning of the year. And what it's really addressing is how you can aggregate IOPS and also the capacity through a front end, and you back it up with a storage layer that you have all the enterprise grade efficiencies, from multi-attaching to snapshotting, replication, whatever it's in your mind. But the really important stuff is that how you can aggregate IOPS and scale on demand. If I want more capacity, I'm going to add to the back end that I'm serving the capacity from. If I want more performance, I'm going to scale out the front end instance. And as you can see in the picture here, it's really going to go down into two stuff here. As you can see, the virtual SAN, which is it's R5P instance, and R5P instance are famous of the high bandwidth of EBS. That means that you have really a high bandwidth to the EBS system. So when you back it up with EBS systems, EBS volumes, that means that you're really gonna get a lot of bandwidth, a lot of IOPS. And just one takeaway here is that it's just a proof of concept. It has not been in general, it's not general availability or in review yet. However, I think this has really revolutionized the idea of storage in the cloud. And I think this is gonna be a huge thing, which is already being adopted by a lot of vendors or companies. Pure Storage, one of them. We have our own. It's the same concept, but we have our own, which has been around for a couple of years. And what I'm thinking, the benefits behind all of this is you can get more out of the storage. There's not going to be any limitations for your dedicated or one-to-one relationship between your EBS volume and your EC2 instance. You can scale. You can integrate with snapshots, backup services. This is actually my intro to Pure now. And what I'm going to be showing you, it's our product in the cloud called Pure Cloud Block Store. And if you are familiar with storage arrays or arrays, we have something, we call it flash array, which is our on-premises array that you can see at the bottom here. A flash array has been around for 10 years. and it's actually it's an all-flash system that is built for performance and for mission-critical applications. What we've done in order to meet our customer needs from having this hybrid mobility and seamless integrations, and you getting your data wherever you want, that means that the same format, the same API that your management that's using is going to be the same. We have built a virtual array or a software-defined array in the cloud. And what we've done is we've mimicked the same way we have our on-prem. So as you can see in the controllers, we have two controllers as a EC2 instance. And to mimic the flash modules and the NVRAM that is receiving the read and make it very accessible, is we have those virtual, we call them virtual drives, which are i3N. And the i3N is famous with its high capacity of instant store. And what we do is actually when you are connecting your applications to this array, you're connecting the front end, which is the controllers. The controllers are getting the request, whatever it is, a read or write, and it's gonna be throwing it down all to this virtual drives, flash to the NVRAM, acknowledge it back, and then flush it down to the instance store. Once it's in the instance store for a couple of minutes, however the algorithm is gonna detect it, is gonna flush it down to a persistent storage and durable storage in the S3, which means that we have a kind of a tiering. So we're not persisting all the data on the instance store, which is more expensive, but we are serving the IOPS back and forth from the NVRAM, and the NVRAM is grabbing that from the instance store. So at the bottom line, we have built a performance appliance that is reliable, because when we think about data, we have high availability from a front end perspective. Both controllers are working in active fashion, means that both can be attached to the volume. And also when you get the data back onto the back end, it's already been stripped down within a RAID HA. And our customers are really loving this, because we have a lot of use cases, but the main ones are migrated to the cloud. Why it's the main one? Because for those customers having flash array, they can really use the same replication features, since it's built in both in flash array and cloud block store. So they can have an async replication or a continuous async replication, or even you can have an active or what we call active cluster between both cloud block stores in one region to another, in availability zone to another. And what it's in the bottom line here is that we are making hybrid easy. So there is no limitation for getting data back and forth between your cloud and your on-premises. So I have here two use cases in particular. One is the migration to and from the cloud, which is relying on the async replication, which is our snapshot-based replication. And as I said, this is what enables hybrid, and also can enable multi-cloud. Because in the same way we can build cloud block store in EBS, you can build it in Azure. You know, this is not, it's a taboo here now. I cannot say that word anymore, but this is what we enable in multi-cloud, for an instance. The second use case, and I always admire this use case because it's one of the things that bringing the storage efficiencies into the AWS. One of those is you can take as many snapshots as you want, and you always pointing to the same blocks. That means that additionally to the thinner provisioning that we have, the blocks, when you're taking a snapshot, we use one of the snapshots technology called redirect on write. That means that I'm not my system or the flash array or cloud block store is not waiting for the snapshot to be taken, which means that duplicating all the blocks to a different segment. But what we're doing is we're just pointing we're just writing, which means that writing the new additional stuff and pointing to them. This is the snapshot. And this is really important because it can eliminate the storage cost, because I'm not duplicating the data. So this is the same thing it's been in FlashArray, and we take it to the Cloud Block Store. I think it's time for a demo. What I've done, it's a very basic one. I've built very quickly a Cloud Block Store in one of the regions, and we have a Terraform provider for it. So this means that I had to click apply for it, and what it does, it's just triggering a CloudFormation that it's going to build all the stack you saw before. The CloudFormation is going to give me an output that includes the GUI endpoint that we use to interact with using the dashboard. And also you can use CLI, your REST APIs that include Python SDK, PowerShell SDKs, wherever. And in order for me to provision a storage, first thing, I guess, let me reconnect here to my jump host. I forgot to show you the instance, the EC2 dashboard. So here you can see that I have a couple of instances, that the ones in saying virtual drive, that's the virtual drives where I have my instance store and the NVRAM using IO2. And the CT1 and CT0 is the front end or the controllers, which is where I'm going to be attaching the application hosts to the volume to the Cloud Block Store instance. So I just got the GUI dash IB here. I'm gonna go and use the default pure user login. So this is the basic dashboard, which is exactly the same one we have on FlashArray on premises. And in order to provision a storage, you don't see any performance here or any latency metrics because it's still new. You go and create a host. The host, you're gonna give it a name, and you're gonna give the port. So for now, we're using iSCSI because everything in the cloud is network-based, but we're adding new features like NVMe over Fabric, TCP connections, and that's going to be included between FlashArray and Cloud Block Store as well. The second thing I need to do to create a volume is just one thing. I need to come here, create a volume, give it a name, host1 volume, give it a number of, it can be whatever, since it's going to be 10 provision. So does not mean that I'm going to be provisioning all the size. I don't need to make it as a protection group volume. Protection group is what we use as a consistency group for replicating or taking snapshot using policies that's define how many snapshot retentions, something like this. I don't need to do that right now. I just give it back to the host. The second thing I need to do is I need to get the replication network, which is can you see, by the way? Sorry, I think I missed that one. Is it there? Thank you. I need to get the iSCSI. And I have a Linux machine, but let me just do that very quick here. For the same jump host, targets, we can have the discovery. And if my security groups are configured well, which means that I need to give access to 3260 port between the security groups, between my EC2 security group and also the other, which is I didn't, I guess. That's gonna take me a couple of troubleshooting stuff. So I have my Windows host here, and what I need to do is just checking that I don't have it. This means I need to give this very quickly. Save. And I'm gonna give it, this is a bad security best practices. I'm gonna back here. And I have it here. This is the connection. I just need to connect. I didn't have multipath enabled yet, but let me just figure out what's the problem. I didn't set up my demo quite well, I guess.
You're using Windows.
That's the problem, right? I should have just used the Linux one. Yeah, I just was.
It's your fault.
It is. Yeah. Blame me. Yes, I actually did it to myself. Yeah. But the bottom line is just what it's gonna happen. I'm just gonna go to disk management. I'm gonna find my provisioned 10 terabyte through the network into the disk management portal here, which is I failed to show you. Yep. I still have 10 minutes, which is we need to move on to the next stuff. Yeah, a couple of stuff here. If you really want to learn about the cloud storage, or you really want to join us, you can check this QR code. We are building a team here in Prague. We already have one established in Mountain View in Silicon Valley, but now we have one here. Actually, Better is one of the guys who joined us a couple of months ago now. And also, if you really want to learn more and understand the other features that we have in Cloud Block Store, we have a lightboard video series that have 5 videos. It's from my colleague Anthony. And the bottom line here is actually what CBS Engineer is going to be doing. We have 3 main teams, one for platform and one for IOPath, which is just going to go and check what other optimizations we need to do for our network. And the automation side, which is include any Terraform, any Python, and other stack features that we are including into the Cloud Block Store. One thing actually I really enjoy doing in my weekends is learning more about AWS storage, and you can even earn badges about it. And if you check the AWS skill builder, you can find a lot of a couple of actually there's 5 of them learning plans that at the end of the learning plan you can just go and do an on-demand exam, 60 question, 50 question, and then you can have a badge in your Credly account.